Hi there. What we have here is a program that's developed based on analytical model for optical microdisk resonator, as you can see here, or ring resonator. This program, so here the goal is to calculate the wavelengths and the modes that light can be coupled into this basically microdisk. This analytical model compared to FEM models is much faster and can calculate many modes for us in a much shorter time. And later we will see actually the error from this analytical model compared to FEM models is quite small and negligible. So here in this program, in the input box, we can insert the data of our model. So for the speed of light, I'm going to leave it as it is, and for this refractive index, so I'm just going to 2. For different materials, so for example for silicon, it can be like 3.5 at some wavelengths, but here I'm just going to choose 2. A refractive index, I'm going to leave it as 1. For this diameter, I'm going to choose 14 micron, and for thickness of the disk, 200 nanometer. So for the radial mode, the number of radial mode that I'm interested to see, let's say here I'm interested to see the three first radial mode, and for wavelengths range, I'm going to choose between 1300 and 2000 nanometer. And for the polarization, I'm just going to leave it as TE mode. Now I can run the program and see the result. Basically, the modes that we have for this microdisk. So each radial mode here is plotted with different colors. So red bars are for the first radial mode, green for the second, and blue for the third. And for each red bar, we can see the wavelengths and also azimuthal mode, basically the number of peaks in the azimuthal direction. But here on the lower part of this program, we can plot actually each mode separately. So let's say first I'm going to choose for radial mode number, I'm going to choose the first radial mode. And here I can choose the azimuthal mode. So based on the solution, I have several options to choose. So let's say I want to plot for the 30 as a number of azimuthal mode. So basically I'm going to be here. So I'm plotting this red bar, this mode, and here I can see the wavelengths and the corresponding frequency of the light that can be coupled in this mode. And if I plot this mode, okay, here I can see, so here this is the top view, 1/4 of the disk, I can see the mode, and since it's a radial mode, in the cross section I only see one peak. So this is the cross, this is the basically looking at from the side on the disk, and also we can see the mode along the radial direction and along the thickness of the disk. Above and below the disk we can see the evanescent tail, and since this is the first radial mode, I only see one peak here. So, and if we count the number of azimuthal in the number of peaks along the azimuthal direction, we get this 30 number here. So let's go to higher radial mode and plot them. So this time maybe I'm just for the second radial mode, I'm going to leave it as 20 for azimuthal mode. So I believe this one would be that I'm going to plot would be actually this last one. The yes, this green bar at the end, and I can see the wavelengths and the frequency, and let me plot that. Okay, so here in this mode I have one peak and one basically one maximum and one minimum, and also yes, so I have one peak and deep here. So we have the second radial mode here, you can see in top view, and also here in the radial direction. Similarly, I can go to the third mode, and let's this time plot it quite high number. I want to choose quite high number for the azimuthal direction. Oh, okay, here we can see, and we can see how basically the number of the maximum and minimum are large along the azimuthal mode, because I choose 34. Here similarly we can see the mode along the radial direction, and that is the program to basically to calculate the modes and the corresponding wavelengths that can be coupled to the microdisk resonator. But also, so if you want to compare this result with the FEM model, so here what I have here is that the comparison of 3 different models. So in the first column I have the analytical model that I just showed you, and in the middle column I have the result from 3D model, 3D FEM model, and on the last column I have the result of 2D axisymmetric FEM model. And what we see here when we look at the frequency at the basically, and all of the results are for the first radial mode, and when we look at the frequency for different azimuthal mode number, we can see actually they are very close. The error is less than 1%. So we can say here here that analytical model can give us quite good result, and it doesn't need as much time as FEM models need to solve a problem. And that is for analytical model with analytical model for optical microdisk resonator. Thank you for watching.